Well, ahoy there. You're going to need some notes. There's a lot of notes in this one. So make sure you have some notes. There we go. All right. What we're going to do for 1.5 is solving equations, but not actually solving them. You are rewriting them so that you isolate a variable, but you can't actually get a number answer. So it'll make more sense in a second. Anytime you have an equation that has two variables in it, two different variables or more, that's called a literal equation. So when you see the words literal equation, what that's saying is you have an equation that has two or more variables in the same equation. So we're going to jump right into this. So here's a literal equation. It's 3y plus 4x equals 9. So it has both an x and a y in the same equation. And it says to solve it for y. So normally when you solve for x or y, you get like x equals 3 or y equals 12. In this case, we're actually going to get y by itself. We're going to isolate y. And we're going to have x in the answer. So what you're going to want to do is first rewrite it. And then they've highlighted y in blue just because we know that's the one we want to get by itself. So this 4x and this 3 have to go away. So what should we do first? Yeah, you subtract 4x on each side, and that's going to move the 4x to the other side. So now you have 3y equals 9 minus 4x. So now we have to get rid of the 3. So how do you do that? You divide by 3. So divide each side by 3, and 3 divided by 3 is 1, so that'll go away. And you'll be left with y equals 3 minus 4/3 x. You can also just write it like this, y equals 9 minus 4x over 3. Both of these are acceptable answers. So that is solving a literal equation. You're not actually getting y equals 9. You're getting y equals 3 minus 4/3 x. You're getting like an equation. Okay, so moving on. Solve this literal equation, y equals 3x plus 5xz for x. So in this case, you're trying to get x by itself, so that's why they've highlighted it. And all this other stuff's going to have to go away. Now, I don't think because of COVID, I don't think you guys had much time to do what's called factoring. So hopefully you remember the distributive property. Anytime you have like a couple of x's and you need to isolate, you're going to undistribute. That's also called factoring. So you're going to pull out an x from both of these terms. That's going to go outside of parentheses. And then the remaining terms go inside. So like if you were to distribute this x, you would get this top part. You are undistributing. Okay, let that sink in for a second. All right, so then to isolate it, you just need to get rid of this whole chunk in the parentheses. So you divide each side by this 3 plus 5z. And then all of this will go away on the right, and you're just going to be left with x. Now on the other side, you have y over 3 plus 5z. So that is the simplified version of this when you solve it for x. Okay, might want to jot that down. It's a good example. Okay, next example. We have surface area is 2 length widths, 2 times length times width, plus 2 times the length times the height, plus 2 times the width times the height. That's a formula for the surface area of a rectangular prism. They want you to solve this for L. They want you to get L by itself. So again, rewrite it first. What do you think a good first step is? Yeah, you want to subtract 2WH from each side because all we want over here are the L terms. So now the L terms are on the right, everything else is on the left. So now we have to undistribute the L. When you undistribute the L on the right, what do you get? Okay, so when you factor out this L here, you're going to be left with 2W plus 2H because that's what you would have if you were to distribute to get this mess right here. Okay, so now we got L isolated almost. We just have to get rid of all this stuff in parentheses. How do we do that? We divide. So we're going to divide each side by 2W plus 2H. That's going to cancel all of this out on the right because this divided by this is 1. And then you're going to be left with L equals S minus 2WH over 2W plus 2H. Okay, so that is solved for L. That's L isolated. All right, let's do another example. Woo, a lot of examples. This might be a long video. I'll try and speed it up a little bit. You have a rectangular lot that's 500 feet deep, and it has an area of 100,000 square feet. You pay for a new water system, and it's $5.50 per foot of frontage. So that's by the road. So this part, they charge you $5.50 per foot. So we have to find how long this frontage is and figure out how much money that's going to cost us. So one way to do this is, the area of a triangle is length times width. We want the width. So we're going to isolate W. You can do that by dividing each side by L. So the area divided by length tells you the width. So see if you can figure that out real quick. All right, hopefully you did 100,000 divided by 500 and got 200. So this frontage lot is 200 feet long. And now you got to figure out how much is that going to cost. All right, so you're going to have to do 200 feet times $5.50, and it is $1,100 is how much you have to pay for the frontage road. Okay, so those are common formulas you've known, like length times width and things like that. Here are some new ones. You want to write these down. You might want to go full screen if it's hard to see. So a common formula is for Fahrenheit and Celsius, and Celsius equals 5/9 the Fahrenheit minus 32 temperature. And then there's a simple interest. So interest, principal is the amount of money you put in. And then there's a interest rate, that's R. And then there's a time that you're leaving the money in years. So the interest is equal to the principal times the rate times the time. That's another formula that's commonly used. And the last one is the distance formula you've probably seen in science, which is distance equals rate times time. And rate is like speed, it's velocity. All right, so make sure you have those jotted down. Those are going to be commonly used formulas. We're going to use some right now. So solve for the temperature F. So given our temperature formula, this is to figure out Celsius. What if we want to figure out Fahrenheit? How do we do that? All right, so what you're going to want to do is first multiply each side by 9/5, or you can divide each side by 5/9, which is the same as multiplying by 9/5. That's going to cancel out this 5/9 over here. So you're going to be left with 9/5 C equals F minus 32. So let that digest for a second. All right, so to get F by itself, what do we do now? Yeah, you want to add 32 to each side. And then the 32 is going to go away, and you'll just be left with F equals 9/5 C plus 32. That is our simplified equation for Fahrenheit. Okay, so I think we're going to use that now. So now use that simplified equation for Fahrenheit to figure out which one's hotter, Mercury at 427 degrees Celsius or Venus at 864 degrees Fahrenheit. All right, so work this out on paper, or you can guess. It's a 50-50 shot. Okay, hopefully you actually use the formula. If you plug in 427 Celsius for Mercury, that'll convert it into Fahrenheit. So Mercury is 800.6 degrees Fahrenheit. Venus is 864 degrees Fahrenheit. So even though Mercury is right next to the sun and Venus is not, Venus is still hotter because of the atmosphere. It's over 60 degrees hotter than Mercury. There we go. Okay, let's move on to another example. You deposit $5,000 in an account, that's your principal, that earns simple interest. After 6 months, which is half a year, the account earns $162.50 in interest. What is the annual interest rate? We're trying to find R. So you're going to want to use this formula. So see if you can use this formula to determine this answer, and then we're going to go over it. All right, so if you want to look for R, you can divide each side by the principal times time, and you get this equation, and then you just got to plug the numbers in. The interest is $162.50. The principal was $5,000, and the time, because it's half a year, is 0.5 or a half. And then when you work all that out, you find out that the interest rate is 0.065, which is the same as a 6.5% interest rate. You just move the decimal over 2 spots if you want to turn a decimal into a percent. Okay, and our last example. Woo, this video is going long. This is a complicated problem, so I'm just going to click through it, and then I'll have you pause and take a look at it, make sure it makes sense. Truck driver averages 60 miles an hour while going to deliver, and then on the return trip, 50 miles an hour. The total time is 6.5 hours. How long does each trip take? Tricky question. So this will use the distance formula. So the distance equals rate times time. So the time, which is what we're looking for, equals distance divided by rate. So D over 60, because it was 60 miles per hour there, and D over 50 miles an hour back, have to add up to a total of 6.6 hours. So hopefully this here makes sense. You might not have initially come up with it on your own, but take a look at that, see if it makes sense. And then to solve this, you need a common denominator. So you'll end up with this expression. If you need some help with common denominators and fractions, just let me know. So then you can multiply each side by 300, divide by 11, and you find out the total distance is 180 miles. And that distance, d, was one direction. That's what it stood for in our original equation. All right, so that one was a relatively complex one. Let me see if I can back up. Oh, I can. Look at that. Okay, so see if this all makes sense. Might want to take some notes on this. And see if this makes sense. You might want to take notes on this. Okay, I'm going to cut this video off now. As you're working through these problems, just let me know if you have questions. Refer back to the notes frequently. These are common formulas we're going to be using quite a bit. Okay, good luck, and I will see you in class. Arr!